Many of you have suggested to use a fan to cool my VTXs while I test them on this bench. That's this video. So I never expected VTX tests to kind of become a thing on this channel. I did the one and you guys loved it so much, so I've carried on, and I guess it's a thing now. I'm planning on continuing them. You guys seem to enjoy them a lot. I enjoy doing them. They're fun, and it really opens up your mind as to what's going on with a lot of these components. And I just kind of like knowing what is going on my quad. Is it actually performing to the standards that it's sold as? Is it going to continue to perform at that? What happens when you turn it on? What happens when you crash and the thing sits there and cooks? Like, I like knowing all that stuff. So, and it's very obvious to me that you guys do too. So anyways, many of you have suggested running a fan on the tests, and it's a great idea, because usually what I do with the VTX tests is I'll get a kind of a cold test where I'll plug it in and get a immediate result, and that's kind of like our high baseline, and then I'll let this thing sit there and cook and see what it goes down to, and see if it levels out or just keeps going down, and I don't let it sit for 20 minutes. I kind of give it a reasonable amount of time, because if you've crashed and it's sitting there cooking, odds are you're taking a while to find it. So you're not going to turtle mode out of it and fly away. So we don't need that reading for it sitting for hours and hours, or 20 minutes, whatever. We need the reading of you plug it in, you walk to wherever you're going to fly from, and you take off and fly. Or you want to land on a building somewhere and just chill out for a couple of seconds and then figure out, what's your VTX going to read? Are you going to be able to take off again and have video, or are you going to do it completely blind? So that's what that test about. But what a fan will let us do is let us know what the VTX is outputting in the air. So I was looking for, I needed a fan that blows a fairly significant amount of volume, and one that also is silent, because you guys don't want to listen to that kind of nonsense. A whirring fan in a video, I mean, maybe some of you will put it up with it, but I personally don't like it. I'm not going to subject you to it, so I'm hoping this is it. So one of you guys had suggested a Noctura fan, and this is one of the silent ones that they make. I mean, most of their fans are silent, but this is like one of the uber silent ones. And then I had popped onto Thingiverse, and I'll put the link in the description below for this guy. This is a 3D printed cover, so nothing can get in there. Not that this fan's going to cause any issue, but it's just like if I got, stuff flying around here, it's not going to get into the fan and stop the fan. Because if the fan is silent and I can't see it and it stops, I guess there's a wind, but whatever. But anyway, yeah, this is kind of a nice little thing. It's tiltable, so that's a good thing. And then if you look at the bottom of this fan, you can see it's kind of hard to see, there we go. You can see both the rotation and the wind direction, so I can set this guy up just like this, and I'll likely do this off camera. I don't know if you guys want to see the feet or something in the shot, so you know it's there. I'll put it where it makes sense in the video, but this will go like this. You can see it's kind of tilted like that, and then I could put the VTX here if you're looking at a cross section of the table, like the table will be here, and then it will cool the VTX. I would like to maybe in the future work on something that'll elevate the VTX. Maybe if I get a frame or something like that and I 3D print some parts so it will stand off the table, and I'll put I'll basically build a quad and have it like a test quad or something like that. But again, that's coming. I got so much stuff to do before I get to that, but this will work for now, and we'll see what we get. So I don't know the miles per hour that this will signify, but what I do know is eventually I want to test that. So I got the fan. It's a 12 volt fan. It's a 1200 RPM. 0.6 watt, 0.05, is that 0.05? Yeah, 0.05 amps, and it is 12 volt. I don't know if it'll handle a 14 volt or what have you. So my plan is to run a regulator on this. So that's basically what this video is. I'm going to set up this fan to run off of. This is a cheapo 6S 1300. I'm going to try to get it to safely run on this. So there's that. Just real quick, let's test this battery. So this battery is at storage charge 22.9. So clearly, if I just went ahead and plugged this guy in, we'd probably smoke this fan. So let's take care of that. So I could run a standard Pololu step-down regulator. The issue with something like that is they've got a potentiometer that you adjust with a screwdriver. It's really small. They're fairly cheap, and you need a voltage meter to see the output. So I picked up this guy. It's twice the price of a Pololu, but it looks way cooler, right? Anyway, so the way this guy works is you get voltage in and voltage out, and you could adjust it with these buttons here. So you can adjust the in voltage here, the out voltage, and then you can, I don't know what set is, and then you got on and off. So I happen to like this. I will 3D print something that this fits into. This is a Drock, and I'll put a link to this in the comments below. Even if you don't run something like this is awesome just to have on your wall or something. This looks like, it looks like it belongs on my dashboard, and then this is like the time machine or whatever. All right, I'm gonna stop. This will handle up to 30 volts, so I'm okay putting a 6S LiPo on there. That's one of the reasons why I picked it up. So to do this, I'm gonna want something to connect on the inside, and I got my 6S battery here. So we're gonna connect this guy here. We want this is the male side. We're gonna put this here. I'm just gonna put it on a little length of wire. And anytime you solder these, especially the male side like this, this plastic gets hot and it will warp. So I always put the female end. And even though the plastic here is male and this is female, we're actually looking at the pins when you determine male from female. So we want that together. And now you can heat this up all you want, and it's not going to warp this as it cools off. I really want a little bit thicker wire than this. This is 20 gauge, and I don't need a lot. I'm just cut off about that much. I've got my Drock, I've got my XT60s, and really something like this I should probably do XT30s, but it's just gonna be easier. I can grab a 4S or 6S and just plug it right in, not have to worry about it. If I do a XT30, I'm just gonna have to use a reducer anyways, so there's that. What I'm gonna do here is strip both ends and tin them, and then we're going to tin this guy here. Now, depending on the connector here, I think usually a connector like this, you don't want to pre-tin the ends, and the reason you don't want to do that is anytime you solder something, the solder is still malleable. So when you go ahead and screw your end into something like this and tighten it down, over time it's going to loosen on you. So I don't think I'm going to pre-tin the end that goes into this guy. So let's get this guy pre-tinned on the other side. And I'm just going to hold it with this. All right, so this guy here. So this guy should also double as a solder sucker, if you will. So, because yeah, it's kind of a problem out here, breathing in all the solder, and I am doing way more soldering than I ever expected to do lately. So we want to play close mind to which side is which. So this side is the positive side. We'll start with that. And I'll place this guy right like that. Is that too much yellow on the screen? Too much yellow. Okay, so let's go ahead and pre-tin this guy. I think we're gonna need a little bit hotter of an end here. Let me change the tip here. Alright, so I'm changing to a T15 D12. This is a chisel tip. It's a little bit thicker than what I was using. The other one, the only reason I was using it is because it was on the iron. I'll show you the tip of this in a second here. There we go, focus on that. So this is a T15 D12. As you can see, it's a chisel tip, and this is going to be great for this here. We can heat this guy up, and I'm going to heat up the backside just a bit, and then I'll heat it up here, and then I can run some solder in there, just like that. And then melt this guy in place, just like that. And what I like about this is now I can just plug that there and load up a bit more solder in this joint. I don't need a ton here, but there's that. Man, let's flip this guy over. So when you have the right soldering iron, it makes a job like this way easier. Way easier. As you saw, done. Okay, so once I got that soldered, I put a little bit of 3x shrink tube on there, and just a small piece here and a couple small pieces here. The reason I like the 3x is you can see it managed to cinch down on both the wider portion of the XT60 and then all the way down to the wire. And this stuff has a heat activated glue in it, so it really tends to hold onto parts. And then I just put another piece there just to hold this kind of as one unit. So that's that. Now we can pull out the female section and toss that aside. And then now we're onto this guy. We need a small screwdriver. And this is the inside. So let's kind of back these open. I'm not sure. I might have to pre-tin these wires. I want to pay attention to which is, yeah, I'm gonna pre-tin these wires. So I've gone ahead off camera and pre-tinned these wires, and the reason being is the screw connections on this are awfully tight and the wire will splay out, and I don't want that to happen. So it is what it is. So we want to make sure we are on the in or the outside, so the inside's here and our negative is the bottom. So go ahead and put that in there, and it will bottom out. Same thing with the positive. Slide that in, and it will bottom out. And then we can go ahead and tighten these down. So there's that. And now the moment of truth. Let's see if this video is a good video or a great video. So I like that this has the digital readout, but we're going to go ahead and test this, and especially because it's really hard for you to see, but this is 22.9 and 0 amps. So I'm getting 22.9, so that's correct. Let's test the out. I've got this set for 12 volts, 1 amp, and we are getting 11.912. That to me is acceptable. So let's see, actually this has an on off button. Will that turn off? It says it's off. I've got a LED telling me it's on. This is in fact off. Perfect. So if I push and hold that, it's still off. Push and hold. Okay. And now it's on. All right, perfect. All right, so a little bit about how this guy works is the LED over here, this red LED right there tells me that these are reading the input voltage. Now, if I switch this to out, it moves over to here. So this tells me that it's reading the output voltage here. And then this guy here, the blue one, if I push and hold this, you can see that that turns off. That means there's no output power coming out of that. So this is nice. I got an on-off switch for the fan. So I'm going to push and hold it, and there we go. And we got our voltage. So let me unplug this. So we have our input side set. Now let's work on our output side. For the output, instead of hacking up a $30 computer fan, I went and picked up one of these guys. This is just your fan connector with some really crappy wire I have to add, but you know, it is what it is. So I'm gonna go and cut this at a similar length. I'm just gonna cut this guy in half. That's what I'm gonna do right here. Whack that guy in half, so we don't need this any longer. And this is what we're going to concern ourselves with. So the plan here is to strip and pre-tin the red and the black. You're probably wondering what the third wire is for. We're not going to use the third wire. The third wire is for, oh, I can tell this is crap wire. This is junk wire. Oh my God. So this is like an Amazon $6 special wire. I hope it fits inside of that end there. But anyway, so we're going to strip and pre-tin the black and the red. And many of you are probably wondering what the yellow is for. We're not going to use the yellow. The yellow is used inside of a computer. That is to relay information to the BIOS to let it know what speed it's spinning at and all that sort of stuff. So, I mean, maybe in the future we'll use it. Today we are not going to use it. So I'm just going to do like I did here and just kind of maybe one of these guys or something, just so it's off to the side. But I'm going to pre-tin these guys first and then cut them down a little bit. There we go. Okay, and we do not need these this long, so whack you about there and whack you about there. Okay, so the yellow wire, as you can see, I just cut and terminated it there, and then put a piece of shrink tube there and there just to hold this all together in one piece. So next we gotta put it in here. This is easy, same thing. Back these screws out. We wanna make sure we have the positive on the top and the negative on the bottom. Once that's in, cinch these guys down. Okay, so there is our setup. Now, let's plug in our battery. So we're reading the output voltage here. We got our input voltage there. Let's go ahead and plug in the fan. Can you see that right there? Okay, my desk is getting messy here, but it is what it is. Okay, so there's that. Let's see what we got on and off. And that fan is running. And if I push and hold this, perfect. And you guys should not hear that fan because I barely hear it. And that's blowing pretty good. And it's drawn 0.3 amps, 0.03 amps, and this is 0.05 amps. So actually what I should do is turn this down to 0.05. So let's do that. We're gonna set that, and then we're gonna run this down to 0.5. Oops, 3, 4, 5, right there. And set 12 volts. So that's up and down over here. So that's it. That's it. That's perfect. And that's blowing a decent amount of air. So let's... Oh, that's exciting. So that is a real quick look at the addition that I'm going to be running on the sidelines of my upcoming VTX tests. This is cool. I happen to like this. I'm going to 3D print a case for this. Because a lot of the stuff on the back here is still sticking out. They didn't even take the time to cut the pins here. I guess I could do that, but still, just 3D print it, throw it in a case, and we're done. And that's gonna look good. I'm also gonna shorten this black wire here because I don't like that. But anyway, yeah, nice little setup. The fan is good. I didn't even hear it as it's running here on the desk. So I'm going to assume you guys didn't hear it. We'll see what it looks like in the edit. So there's that. I mean, this is a nice little setup. So if you're looking to test VTXs, this is a pretty good setup. This cost me, if I don't include filament cost, the fan was $30 or $32, and this was $12. Many of us should have the XT60s kicking around and the batteries. So there's that. So yeah, if you're looking to do VTX tests like me or are interested to see how I will be cooling it, this is it. So if you enjoyed this video, go ahead and click that thumbs up button. And if you haven't done it already, like 92% of you have not, go ahead and punch that subscribe button, because you only get to do it once and it's fun. I'll catch you later. Peace.